Hey guys, it's Alyssa in Math for Elementary Teachers. This is the Chapter 14 Teach It assignment, and I'll be doing problem number 20 in section 14-2A, just parts A and C. So let's get started. Let's look at the book here first. I drew mine on it, but let's look at the book first. It says, find the area of each of the following shaded regions in parts A through D. Assume all arcs are circular with centers marked, and then leaves all answers in terms of pi. So I drew out around over here so we can mark on it, write around it, make sense of it a little bit easier. So we have to find the area of just the shaded region for part A. I drew out this very important area formula here. This is area of a circle. Area equals pi r squared or pi radius squared. So the first thing that we're going to do in part A is actually find the area of this entire big circle. That's the first thing that we're going to do. So I'm going to write area, I'm going to write big, and that's going to help us remember what we're doing here. So to find the area of the big circle, we have to find our radius. We can see that the radius of one of our small circles is going to be 1. If we extend that radius into a diameter for a small circle, that's actually going to be the radius for our big circle. So our radius for the big circle is going to be 2. So let's plug that value in. So we've got A equals pi, and then we said our radius of a big circle was 2. So plug that value in, 2 squared. If we take 2 squared, we're going to get 4, and we leave that pi there. So the area of our big circle here is 4 pi centimeters squared. Centimeters is our label, and for area we always square that. So that's our area for our big circle. And the next thing that we're going to do is find the area of a small circle. So just one of these right here. So I'm going to write this out here so we can keep track of what we're doing. For the small, we kind of already know what we're working with. We have pi, again, and then our radius squared. We already know that our radius is 1 because it's labeled, so we're just going to put 1 squared. 1 squared is going to be 1 pi centimeters squared, and we can actually just leave that 1 off. That's not necessary, so we can just put pi centimeters squared. Now that's for one of the small circles, but because we have 2 small circles, we actually have to take that answer times 2. So 2 small is going to be pi centimeters squared. We're going to take that times 2. So we just need to put that 2 in front. So 2 pi centimeters squared. So this is our area for both of these small circles combined. So the final thing that we're going to do here is we're going to take the area of the big circle, this first one that we did here. So we have 4 pi centimeters squared, and we are going to subtract the area of the 2 smaller circles, so this 2 pi centimeters squared. Now we're doing this because we want to find out just the area of the shaded region. Right now we have the area of the unshaded region, and we have the area of the whole thing. So the only thing that we have left to do is find that area of just the shaded region, and we can do that by subtracting here. So we're going to take 4 minus 2 is 2. We're going to keep that pi in there. So 2 pi centimeters squared. And that is going to be our answer for the shaded region of this circle here. So this shaded circle part, the shaded region of the circle, big circle here, is equal to 2 pi centimeters squared. Now on to part C here. Again, we have to find the shaded region in this circle. And once again, I included this very important area formula for a circle. Area equals pi times the radius squared. So the first thing that we have to do here is, despite my drawing, we have to understand that the shaded region is actually going to be equal to the unshaded region. And we can do that by taking this top section of the shaded region and just flipping it with this smaller section here. And I know it doesn't look like it in my drawing, but in the book they actually are equal. So we can just pretend to flip them around, and we'll understand that the shaded region is equal to the unshaded region part of the circle. That's just something we have to keep in our mind for later on. So the first thing that we're going to do is find the area of the whole circle. So this entire thing, not just one section. So again, right here, this little bar here shows that the radius of one of the small sections is 1 centimeter. As we talked about in the first one, if we're going to extend that radius out into the whole thing, that's actually going to be 2 centimeters for the big circle. So let's plug those values in. Area of big, and I'm going to put that again so we know what we're working with here. Area of the big circle we're going to have pi times the radius squared. In this case, it's 2 squared again. So we've got 4 pi centimeters squared because, once again, it's area. We always square our answer. Now, to find out how much of this is shaded and unshaded, we're going to take the 4 pi centimeters squared and we're going to divide it by 2. And that's going to give us what each part is equal to. So 4 divided by 2 is 2. We got 2 pi centimeters squared. And that part tells us that both the unshaded and the shaded region, the area, is 2 pi centimeters squared. So our final answer for the shaded region is 2 pi centimeters squared. And that is going to be our answer. So for part C, we did the whole circle area, and then we just divided by 2 because it's an equal divide between shaded and unshaded. I did that backwards, but shaded and unshaded. And we found out that the area for the shaded region is equal to 2 pi centimeters squared. All right, thanks for watching.